Hello, I'm Saidal Jedi, and this is my final Demo 9 video. Um, and in this video, we will be demonstrating um, the operation of the full operated or the full controlled microprocessor. The microprocessor or the circuit here runs through four main states, which are idle, load B, load A, and store. You can see how we reached this part by looking into um, the next state logic and the address generator right here. Um, I also labeled every part of this microprocessor in red. As you can see, this is the processor part. Over here is the read-only memory, or the ROM, and over here is the random access memory. Of course, I should have labeled these as well, but I thought I didn't need to because these are components that are external and they're into the processor, but they're not connected in such ways. And as we move through the circuit, you will see the modes or the states of the processor change from idle to mode B to mode A and store and such. We have the select input right here. This indicates what mode is the processor doing, or what mode is the ALU mini over here that we made before. Like what mode is it doing? So for example, it's in 0 here. If we make it 1, it's going to be adding A plus B from the store. Okay, so let's start by doing a simple addition, since we already turned on or put it into the addition mode. We'll do a simple addition operation. So let's say we want to add ROM 0 and ROM 1. Say we want to put ROM 0 to 7 right here, and ROM 1 we will put it into 1. Now we go to the decoder and basically set it. So we are starting with ROM 0, which is going to be, we're going to set it to 0 right here, and address 2, which is A, we're going to set it to ROM 1, and the output we want it to be, let's see, we'll do it for RAM 6. We'll make it output in RAM 6. Okay, so let's start this. What we'll do here is we'll enable the auto click. So basically what we'll do is it will start at it will add address 1, which is B, with address 2, that is A, and then output it at address 3, which is the output. It is set to RAM 6. So let's start. And as you can see, RAM 6 is 8, which is 7 plus 1. And we can see here the state that the processor is working at as well. Okay, so now let's do something different. Let's do, for example, we'll do division. Alright, so let's set the mode to number 4 right here, which is divide values. And let's see. Let's try and divide 2 over 1. So we'll divide 2, which is, we're going to do A over B, 2 over 1, and we want to output it at RAM 5. Okay, so let's set values. For example, we'll do 9 by 3, which is supposed to output 3. Alright, so we have 9 here, we have 3, um, as you can see here, it's supposed to divide divide address 2 by address 1, or ROM 2 by ROM 1, and then output it at RAM 5. Now let's enable the auto tick and then start. As you can see here, RAM 5 gives out 3. And you can see as well the state it is in from here. Finally, we'll do one last simulation, but this time we will use values from the RAM instead of from the ROM right here. So we have RAM 5, which is equal to 3, or outputs 3, and we have RAM 6, which outputs 8. We will, let's do subtraction. So let's set mode to 0, and then we want to subtract RAM 6 or RAM 3 from RAM 6. So A is going to be address 6, and we want to subtract RAM 5 from it, so it's going to be 8 minus 3, or RAM 6 minus RAM 5, and we want to output it at RAM 7. We have the clock here. As soon as we enable auto click and as soon as we click on start, it should output the right value. And as you can see right here, RAM 7, let me zoom in, is outputting 5 right here. And this was my final demo. Thank you for watching, and goodbye.